In today's lesson, we're looking at solving quadratic equations. So this is looking at the notes in front of you. So what we've been doing so far with our quadratic expressions and equations and things like that is we've been factorizing them, putting them into brackets. And there might be a case of, why are we doing this? Are we just trying to, make our heads explode? No, there is a discernibly good reason that we end up doing this. It's so that we can find out what those values of x are in order to solve particular questions. So we'll start with this thing that we call the null factor law. There, everyone's super polite. Excellent. I've got here 2x is equal to 0. So if I had 2x, which you might remember here as being 2 times x, so 2 times x. If I had 2x is equal to 0, what would that mean that x would have to be equal to? 0, yeah. And I suppose you could do this by dividing both sides by 2. 0 divided by 2 would in fact be 0, yeah. Now, this next one over here, I've got a times b is equal to 0. So what could the values of a and what could the values of b be? Put your hand up, Miss Hartwick. Yeah, there could be 0 and 1. It's a fabulous idea. So this could be 0, this could be 1. What else could they be? Mr. Schwab, directly in the middle.
Any number, really.
Okay, well, could it be though? Because if a was 10 and b was 12...
Any number times 0.
So therefore, what would be the relationship that it has to be? Miss K.
A is 0 and then B is anything times 0.
Precisely, or it could even be 0. In other words, a...
Could it be 0 though? Because it's like 2, it's A and B.
Yeah, yes, very good point. As Miss Hartwick was saying, could there be 2 zeros? Because we usually assume that if I've got 2 different pronumerals, they have to be 2 different values. I'm afraid that mathematicians are also jerks, and technically speaking, they can be the same number. In fact, if you ever have some spare time, look it up on the internet how you can make 2 equals 1. And it's that exact principle. So A could be 0. B could be 0. Or both could be. And I'm going to put technically. Because really, it shouldn't be, but it could be. Okay, so A could be 0, B could be 0, and if one is 0, the other could be any number. Doesn't matter which one is which. Okay, given that understanding, I've got here, we've got some delightful wah-wah accompanying us this afternoon. There we go. It appears at any moment a 70s cop chase is going to happen at any moment. So,
There it is.
I was so disappointed. I was hoping that there was going to be a 70s cop chase right then, but my hopes are dashed. Okay, so I've got here x times. So remember, if I've got a brackets are another way of saying multiply. If I've got x outside of a bracket, that's the same as saying x times brackets x plus 4. So what could we say could be the potential values of x for this one? I've got x brackets x plus 4. Well, let's start it this way. So it's x times brackets x plus 4 equals 0. So what could x be equal to? Yes, Miss K. It could be equal to 0. Yeah, because 0... sorry, pardon?
Any number.
Well, yeah, or it could be any number in this instance. But going back to the idea of the a and b is equal to 0, x could be 0 or any number.
Both x is the same.
In theory, yes, they are the same, but they could potentially have 2 possible values. So, yeah. Can anyone think of another scenario where if I was to do that, it would equal 0? Mr. Schwab on the end.
-4.
Okay, how did you get -4?
Well, the bracket on the brackets could equal to 0. And
Yep.
that would make the equation true as well.
Precisely. This bracket is also potentially equal to 0, because remember, x times this bracket equals 0. So either x equals 0 or this bracket equals 0. So if I was to solve this equation and get -4 on both sides, x could be equal to -4. So in other words, here, x could be equal 0 or -4? Or if you, I suppose I could see an anal retentive mathematician getting very cross with me, and they would want to have the smallest number first. -4, 0. There we go. So -4 or 0. So, given that pattern in mind, let's have a look at this one. I've got 2 brackets here. What do you think? What do you think the values of x could be for that bracket on the right?
0.
Okay, so hang on. Let's get some hands up. Miss K, what do you think?
-2.
So where would you get? That says -7, and that says
I was
plus
looking
1.
at the wrong question.
Oh, that's all right. This one up here.
-11.
Okay, so it would mean that either x minus 7 is equal to 0, or x plus 11 is equal to 0, or both. So if I was to solve these equations, minus. Okay, so the point is that you're trying to find values of x such that one of the brackets would be equal to 0, or the other bracket would be equal to 0, or both would be equal to 0. So in order for this to work, it would need to either x be equal to 7 or x is equal to 11. So my final answers is either equal to 11 or 7.
Is that how you write the actual answers?
Yep.
Could it be?
Sorry? If you replaced x with 0, I'd get -7 times by positive 11. Yep. So the null factor law is what all this business is, and it states that if I've got a times b equals 0, then either a equals 0, b equals 0, or both do. Okay? So, in fact, actually, yeah, we've got a couple of examples that would probably also answer Josh's question before. So we'll start with this bracket here. So I've got this bracket here times by this bracket here equals 0. So what I would do is I just make them both equal to 0. 3x plus 2, I would minus 2 on both sides. 3x is equal to -2. So therefore, x would be equal to what? -2 over 3, or -2/3, yeah. Or I had a weight. Yep. So,
Where did the 4x come from? 4x.
sorry. Oh, no, that's the next question.
Oh my god.
So I'm so sorry. That's the negative question. That's the next question. Sorry, I should label these.
I'm so scared. What is this?
Sorry. There we go. I'll label those.
Okay. Biggest heart attack.
-2, both sides. X is equal to -2. Therefore, x is either equal to -2 or -2/3. Well, it couldn't possibly be equal to 0 because if I replaced x with 0, I would get 2 times 2, which is 4, and 4 does not equal 0, so it can't be equal to 0. Okay, with B, you'll notice there's a thing at the front of the brackets. If there's anything, yes. Yeah, okay, yes. Well, yes. Whatever the letters is, it says B and then J. I'm looking at this example on the right. So, if you have something in front of the brackets, so that's a negative. Guys, thank you. We've got a -1 at the front. So the easiest way to do this would be just to divide everything by -1. Because what's 0 divided by -1? 0. So, well, some people might want to know where the minus went. So that's why we're rewriting it. So, then I just make each one equal to 0. And then we can minus 1.2 from both sides. And either x is equal to -1.2 If I minus 0.5 from either side, x is equal to negative 0.5. So for the next one here, it says 4x squared minus 6x equals 0. Probably the first thing I would do, when you're factorizing, one of the things I would suggest you would do before any sort of complicated, completing the square or anything like that, is see what's in common. And I can see that a 2 can fit in both 4 and 6. And I can see that x can fit in both, so I'm going to factorize like that. Because what is 4x squared divided by 2x? 2x, yeah. Negative 6x divided by 2x? Minus 3, yeah. So either 2x is equal to 0 or 2x minus 3 equals 0. So either x equals 0 or 2x is equal to 3, just adding 3 on both sides, and x is 3 over 2. So my two possible answers would be 0 or 3 over 2. This one is another example of what we're talking about when the thing on the right is not a 0. This time it says 9. So I would suggest you might want a minus 9 on both sides, because hopefully if I minus 9 on both sides, you might see a little bit of a pattern. That was something that we dealt with in the quick questions. Can anyone see what this could potentially be factorized to?
Oh, it's okay, yeah.
Oh, it's an okay, yep. There we go.
It's a complete square.
6x minus 3.
Yeah, so yeah, it's a difference of perfect squares. What's the square root of 36? 6. What's the square root of x squared? And the square root of 9? Oh, I'm sorry you can't see. Let me just zoom in. It's okay. Okay. So, either 6x minus 3, listening up please year 10s, equals 0, or 6x plus 3 equals 0. 6x equals 3, 6x equals negative 3. Oh look, you'll notice here, if I divide both sides by 6, you'll notice here that x is equal to 3 over 6. I'll just zoom out again. X equals 3 over 6 or negative 3 over 6, which would be the same as 1/3 or, no, 1/2, dear. 1/2 or negative a half.
Oh, so do you have to do both? Okay.
Yeah.
Do we have to do half?
You always need to make sure, or if you wrote 0.5, that is okay. Just needs to be the simplest most form. Okay? The last example I want to do is, because we've had plenty of practice on factorizing, I just want to do this last one, F, because we've got to move on expediently so I can get you to keep working on things. It says x squared minus 3 is equal to 5x. So again, I would minus the 5x so that I can make it equal to 0. So I need to factorize these. Can anyone think of a number or two numbers that multiply together to get negative 3, add together to get negative 5?
Can you just randomly put subtractions anywhere?
X and X.
So we've got x and x there, yep. You can. Oh, well, I can make, it's still the same equation. I've just moved the negative 5x to the other side, just like I would with a linear equation.
Right, okay.
Some kind of 3 and 2.
Yeah, so some sort of 3 and 2. Well, it wouldn't be 2. So, let's go and see. And there is no numbers. This can't be factorized. So, this is actually, this is a question from the textbook. So what we'll have to do, if we can't factorize it, we'll have to complete the square. So this one will have to complete the square. So,
It's a massive square.
so we'll complete the square, which I'll do as our next example. But what I'll do actually, I'll just solve this so that we can move on. Minus 3 is equal to 5x. And you'll get these two friends. Or you'll get two little square root numbers there.